So good morning again. This is our third office hours today, October 18th, and we have today another SME, and then Ms. Vita. She will be talking about EMR, Amazon EMR, which is another service that features within the data analytics space in AWS, and this is intended for you folks to have a better understanding of how this service works and how you can use it in the Datathon coming up next month. I have my colleague Iso as well today. So if you guys want to say something, Clarence, any introductions, anything that you want to say before we start today?
Yep, sure, I'll jump in. Thanks everyone for joining this morning. This is our third AWS office hours for the UN Datathon. I'd like to thank our colleagues from AWS again for putting these on. Um, we've been having these to help prepare you for the Datathon, and so you guys can be prepared and do the best that you can. So the recordings if you missed the past two office hours, they're available on the website. There will be one more next week. Keep an eye out on your email for the link to that one. And I'll give it to Seta now. Thank you.
Sure. So like we did in the last office hours, we're going to be taking notes of all the links that I shared today. And then we're going to be sending a follow-up email later with all those links and other helpful resources that you guys can use. Without further ado, Iso, if you have anything to say, well, you can say now, or we can give the word back to, or give it to Shweta today.
I think everything is good. Give it to Shweta.
Thank you, everyone. So I'm really excited to be a part of today's office hours, and we're going to be talking about big data analytics with Amazon EMR. I understand that you all did sort of an intro on SageMaker for the previous office hours, so I really wanted to take the time to introduce EMR and how you can integrate this open source big analytics tool with SageMaker. So I am also joined by Manbinder Singh. He will be doing the demo to show how EMR works in the console, how you can interact with EMR, create different jobs with EMR, as well as showcase an Amazon SageMaker, as well as Amazon EMR integration. So we'll be doing that demo shortly after this sort of 101 presentation. And again, throughout this presentation, please feel free to ask any questions in the chat. We will have some time afterwards to just go over like a Q&A session, but if you do have any questions in the meantime, feel free to just put in the chat. Don't hesitate to put anything in the Q&A as well. But without further ado, let's get started. So I first wanted to talk a little bit about the trends and challenges with big data, right? And first, we have to really keep in mind that the data is growing exponentially. The sheer size and the scale of data has been growing more and more over the recent years. And in the next 3 years, there will be more data created than in the prior 30 years combined. And if you really take that, it's kind of a lot to digest. The old on-prem tools and data stores are not going to be able to handle this kind of scale. Second, the data is coming from a variety of different data sources, right? And this data is typically stored in silos in an on-prem data center. For those of you that aren't aware, a data silo is a collection of data held by one group that is not really easily or fully accessible by other groups in the same organization. And that really impedes the data access and collaboration, right? You want your marketing team to be able to access the data to create visualizations from the developer team, right? We want to be able to create that collaborative environment so that multiple entities within an organization, within an enterprise, is able to securely collaborate with that data. The third thing is data is becoming increasingly diverse. The type of the data that we're ingesting is very varied, right? We have structured data, unstructured data like clickstream data, semi-structured data. So we're dealing with all of this different types of data, and we want it to be captured in an appropriate way so that we can further analyze that data. So now that the data is being collected, customers, again, what do they want to do with this data? Data collection simply isn't enough. What are we trying to do? We're trying to gain insights from that data, make visualizations from that data, share the insights, right? So organizations need to easily access and analyze all different types of data, like log files, clickstream data, voice, and video. But people have a diverse set of skills and tools, right? So we want to make sure that we're creating and leveraging different types of tools that are catered for different types of people that have, these varied skill sets. So we need to be able to enable those people and the applications to access the data, but also ensure security, privacy, and compliance regulations are met for the specific type of data that we're dealing with. So they need to carefully be able to define, monitor, and manage who has access to the specific pieces of data. So how exactly do we set up this sort of infrastructure, right? So let's talk about self-managing analytics services and what you would kind of do to deal with these varied data on-prem. So if you were to collect, secure, and store and process all that data on-prem, it becomes incredibly time-consuming, complex, and even expensive over time, right? If you were to pick up an open source project and set up the environments, it needs a lot of expertise to really ensure that the open source projects integrate really well and are able to work well with one another. And big data administration skills are incredibly hard to find. But even if you have that taken care of, right, you're able as an enterprise to really curate this group of individuals with the expertise needed. The infrastructure might not scale as needed. The innovation and development is always limited by how many resources you have. And costs are very variable to add up incredibly quickly, right? There are few commercial vendors who provide integrated big data platforms, but their pricing is, incredibly expensive to curate that. And there's a lot of capacity planning that's involved. And also for licensing, right? The renewal period, you really have to keep track of that. And with licensing, really calling these different types of vendors, making sure that the resources are being able to be collected in time. These costs multiplied together are likely to add up very quickly. And also the lock-in, right? Any enterprise solution that's on-prem comes with some sort of lock-in that makes it really hard for you to move quickly out of that solution if it doesn't work anymore. So to really address all these concerns, AWS, we built a managed big data platform that scales really easily based on processing needs, while also keeping some of those costs low for you all. So customers are only paying for what they use. And also the great thing about Amazon EMR, which we're going to introduce very shortly in the next slide, is that you're able to separate sort of that compute costs as well as storage. So let's talk about what is Amazon EMR and how do customers use it. So Amazon EMR is the industry-leading cloud big data platform that's really ideal for data processing, interactive analytics, and machine learning using open source frameworks like Apache Spark, Presto, Trino, Hive, HBase, Hoodie, and Flink. Apologize. Let me go back to the slide. So with EMR, you're really able to run petabyte scale analysis with less than half of the cost of traditional on-prem solutions, and without all of those risks and complications that come with on-prem solutions, like we discussed in the previous slide. With EMR, it makes it really easy to process that petabyte scale data. And the great thing about EMR is that it does run directly against your data that's stored within your S3 data lake. And so for those of you that aren't familiar with S3, it is our durable and secure storage service here at AWS, where you're able to store different types of data. And the great thing about this is that it runs directly. You don't need to move that data or transform that data for EMR to be able to process the data. So you can directly integrate it with your data store. Additionally, there is 100% compliance with all the open source APIs, so you don't really need to change your application code when you move to EMR. We have all of those configurations for you to ensure that your data is being run in a compliant environment. Of course, it is the customer's responsibility to ensure that the data meets all the compliance needs, but EMR does offer that environment to run compliant data. With EMR, you can also create clusters and provision not only one, but hundreds or thousands of compute instances to process your data at any scale. And the great thing about EMR, since it is managed infrastructure, it does automatically manage cluster sizes, and it scales up or down based on the utilization. So there's no need for that capacity planning or additional infrastructure overhead that comes with managing your own on-prem environment. So let's talk a little bit about why do customers use EMR? What do they like about EMR, right? You're really easily able to build data lakes as part of your modern data architecture for scalable data analytics. And the key word here is scalable, right? That scalability is sort of lost when it comes to building that on-prem environment because, again, the capacity planning, and as you get terabytes and terabytes of data, you want to ensure that you have a scalable infrastructure and you have all of those resources needed to scale up and down easily. And again, in turn, this will save a lot on costs in the long run. Customers also want to query petabytes of data, both in batch as well as real time. They have different types of data that they're analyzing, and in the future, they may want to integrate both data sources, integrating historical data with clickstream data, for example, to really derive insights. Thirdly, they want to migrate from expensive big data solutions to really gain that flexibility and autonomy over your data. You want to make sure that you're in control of where your data is, but you don't want to sacrifice on costs. To gain insights using BI tools and also prepare your data for machine learning. I talked a little bit about how we're able to integrate Amazon EMR with SageMaker, but you're really able to use these big data analytics tools to build these large machine learning models as well. And if you do want to visualize your insights, you can use BI tools, and we do have an in-house Amazon QuickSight, which is our visualization tool that allows you to visualize your queries. And lastly, building data applications using notebooks and leveraging other analytics services that we offer. So one of the most significant concerns that we see from customers, of course, is costs, right? And cost savings for EMR is not just support costs, but there's also savings made in hardware acquisition, personnel costs, maintenance costs. For data platform administrators, their pain point with Hadoop is the management costs of Hadoop clusters, which include node provisioning, cluster setup, Hadoop configuration, version upgrades, cluster tuning, hardware setup, and things like that. And the message to data platform administrators is the fully managed, right? They can deploy a cluster in within minutes using EMR without having to do any of that typical management activities and continuous making sure that everything is up to par that they previously have to do. So you can really focus on the querying, running jobs, that data analytics, whereas focusing less on that overhead that comes with management. So this slide is incredibly important because it does share these flagship customer successes with customers that have had their infrastructures and currently do have their infrastructures running in AWS and are actively using EMR. Epic Games, for example, collects billions and billions of records. They're virtually tracking everything within their games, and they have more than 250 players, right? So Epic is actually using Amazon, or 250 million players. Epic is actually using Amazon for batch data processing as well as their real-time analytics, right? You want to continuously update points for your players and ensure that everything is being tracked real time. So they are utilizing EMR for both different types of data and processing. Salesforce, SFDC, their marketing cloud, DMP, runs over 3,000 EMR clusters on the daily, using Spark as well as MapReduce for their data science components, batch workloads, as well as on-demand segmentation. GE Power, their Predix solution grew from 8 gigabytes to 200 terabytes. So of course, they moved to AWS Cloud to really support their scalability and demands. And they're currently using EMR to ingest and process 1 million data executions per day, really helping their end clients gain faster insights. Asturion uses Amazon EMR to gain visibility from structured as well as unstructured data sets to learn customer behavior and insights for over 290 million of their members. They quickly realized that they were able to obtain a lot of cost savings. In the long run, approximately 55% of their costs reduced from when they were running on-prem. They also utilized on-demand instances as well as reserved instances for their different pricing to be able to save costs on the long run. Zillow performs machine learning jobs for personalization, so they're able to integrate EMR with SageMaker to allow recommendations. Zillow also used EMR to compute near real-time estimates on 100 million homes within a couple hours instead of one day. So they greatly reduce the time that it takes for them to compute and process and analyze the insights that they want to obtain, just so that their end users are able to get those results a lot faster. So let's take a look at FINRA, right? The Financial Industry Regulatory Authority. So they're one of the largest independent security regulators within the US. And FINRA was actually established to help watch and regulate financial trading practices. So to respond to rapidly changing market dynamics, FINRA actually moved its market surveillance program to AWS to analyze and store approximately 90 billion market events every single day. FINRA selected AWS because it offered the right services while also fulfilling the company's security requirements, right, by using these dynamic clusters. So they really leveraged both Amazon S3 as their storage, as well as EMR to really create that flexible platform and adopt to their changing analytics. So I did want to touch base a little bit on Glue versus EMR, right? Data integration and ETL, because they do have some overlap, but there's very different use cases where you would want to leverage one over the other. So just a small introduction of Glue, for those of you that aren't aware, AWS Glue provides both visual and code-based interfaces to make data integration easier. And users can more easily find and access data using the AWS Glue data catalog. So why would customers want to use Glue, right? Customers prefer the built-in capabilities, connectors, transformations. Glue is really ideal for simple ETL. If you don't have that as much data, or if you want to just use the visual properties of the Glue Studio, low code, no code, that's when they would want to really use Glue. EMR serverless, on the other hand, is big data analytics. It really supports that open source framework, and that really is that difference between Glue and EMR. It has Hadoop, Spark, Presto, Trino, Hive, HBase, Flink, Pig, Hue, and TensorFlow. There's also multiple deployment options with EMR. You could do EC2, EKS, which is Elastic Kubernetes Service, as well as serverless. And we're going to talk a little bit more in depth about the different deployment options and what fits your use case and needs. But if you do have Hadoop migration from on-prem or other cloud providers, EMR is really ideal, and specifically EMR serverless. If the customer has expertise beyond just Spark, you want to be able to leverage all of those different open source frameworks, the customer would choose EMR over Glue. So these are sort of the differences between the two. So what is new in Amazon EMR? So far, we talked a little bit about cost as well as performance improvement when it comes to reducing runtime and deploying resources within a matter of minutes versus multiple weeks that comes with on-prem in allocating resources. So let's talk a little bit about the additional capabilities, right, when it comes to performance, compute, and cluster management. So EMR pricing depends on the instance type, right? And the number of EC2 instances that you deploy, as well as the region that you launch your cluster. On-demand pricing offers low rates, but you can also reduce the cost even further by purchasing reserved or spot instances. Spot instances offer a lot of savings. It's as low as a tenth of the on-demand pricing in some use cases. The instance fleets configuration for a cluster offers the widest variety of provisioning options. With fleets, you can actually specify the target capacities for on-demand instances, as well as your spot instances within the fleet. So when the cluster launches, EMR provisions instances until those targets are fulfilled. You can also select multiple subnets for the different availability zones. And when EMR launches the cluster, it looks across those subnets to find instances and purchasing options that you specify. In terms of cluster management, EMR provides configuration options that control how your cluster is terminated automatically or manually. So if you configure your cluster to be automatically terminated, it terminates after all the steps are complete. So this is sort of referred to as the transient cluster for day-to-day jobs that you want to run. If EMR detects a large-scale event in one or more of the availability zones, it'll automatically route the traffic away from the impacted availability zones and try to launch clusters in alternate availability zones per the customer selection. So you can really ensure that there's high availability when it comes to using EMR. So let's take a look at the 4 big themes for why customers really choose EMR. And first, we'll talk about cost and performance. So it provides multiple performance optimization features for Spark, right? With Spark on EMR, you get 3 times faster performance compared to standard Apache Spark, right? And with all the enhancements, you can really utilize the faster performance for your Spark workloads while also remaining, again, that 100% compliant with the open source API. So let's take a look at the managed scaling. EMR customers, they've been enjoying the auto scaling feature for a really long time. This is where you really get to define the metrics based on which EMR cluster can scale out or scale in to meet that varying demand. So the more data points, the faster reaction time. You save significantly on costs because you're not over or under provisioning. And there's high resolution metrics enabled with managed scaling. And again, you can really monitor all of the scaling features and how successful it is for your clusters using our CloudWatch tool, which is ideal for monitoring all of our services. And also improvements in cluster startup time. So we have reduced the time to start clusters in a private subnet by approximately 35%. We reduce the time it takes to provision task nodes, and customers are actually going to be able to provision task nodes the same time as core and master nodes. Additionally, for clusters that are launched using CloudFormation, they'll observe even a greater additional reduction of 2 minutes on average while provisioning task nodes, as well as enhancing EMR's integration with CloudFormation. We're also able to reduce that start time for clusters launched in a private subnet by 2 minutes. And we do this by maintaining a set of idle, ready-to-use proxy instances, as well as optimizing retry policies for EC2 throttling. So we have vast improvements in cluster startup times, and it really allows customers to provision the resources they need quickly and efficiently. So let's take a look at ease of use. So I wanted to introduce EMR Studio, which is a feature of EMR. It is the IDE, so the integrated development environment that reduces the time for your data scientists and data engineers to build and deploy code, right? It's fully managed with a single sign-on to Jupyter Notebooks, automated infrastructure provisioning, as well as job diagnoses. You can use corporate identity to log directly into the notebooks instead of making users and roles for the employees within your organization. There's no need to log into the AWS console. You can, manage notebooks using corporate identities via the single sign-on feature that we have at AWS. So let's take a look at the features, right? There is IAM federation and authentication support. You can also write Spark SQL, scale up PySpark cells within a single notebook. There's auto terminate on idle customer clusters, so it saves a lot of money in the long run. There's real-time co-authoring of notebooks, so you can have multiple developers within your enterprise coding and developing and being active on the same notebook. There's SQL Explorer with Presto support. You can mount workspace directories to your EMR clusters as well. And we do offer the latest in Jupyter Lab, Livy, and Spark Magic. So thirdly, let's talk a little bit about transactional data lakes. And for those of you that aren't aware of transactional data lakes, it's just more flexible than traditional data warehouses because these transactional data lakes can handle a wider variety of data sources, formats, and structures. So this means that the organizations can store all their data in one place, making it easier to manage and process that data. And EMR 6.9 includes Apache Hoodie, Apache Iceberg, as well as OSS Data Lake. So this is just the ingestion feature for transactional data lakes. We do have reader and writer isolation, concurrent write support, record level upserts, SQL DML support. These are just some of the different features that comes with ingesting onto the data lake, as well as querying. So really efficient queries across partitions and files. Partitioning just really enables for that data to be queried at a faster rate. Of course, compressing the data formats to columnar versions also greatly reduces the time to produce results and querying incremental query support, as well as time travel query support. So as far as administration goes for the data lake, there is asynchronous background compaction of the files. We're really able to do a lot in the background so that the customers can focus on the development. This is just an intro to Apache Hoodie. Apache Hoodie specifically is an open source data management framework to simplify incremental data processing and pipeline development. So the new features that we have within Apache Hoodie with EMR is the multimodal indexes, improving the lookup performance. So it takes less time to perform lookup queries. With data skipping, only scanning the data that's relevant, asynchronous indexer service, indexing columns in the background without affecting any of the writes, and schema on read for Spark, which is just improved schema evolution support. Apache Iceberg, some of the key features include merge on read, optimistic concurrency with Glue Data Catalog. Glue Data Catalog, again, stores sort of that metadata. The data is still going to be stored within S3, but as you can see, EMR has a lot of integration with several different AWS analytics services within our environment. There's also disaster recovery with S3 access points. OSS Data Lake, it's packaged as a library within EMR, and it does support Spark 3 and Trino. So let's take a look at security. EMR really offers a comprehensive set of security features. For isolation, customers can use VPCs, virtual private clouds, private subnets, as well as security groups to really ensure that that it's not going throughout the public internet. It's incredibly secure. For authentication, EMR does support IAM, single sign-on, Kerberos, as well as LDAP. And for authorization, the default option is the cluster's IAM role. We have built a new capability to enable user-level execution and really enable those fine-grained access controls using AWS LF, as well as encryption at rest and transit. That's definitely important when it comes to data collaboration amongst different members of your enterprise, as well as making sure that we're auditing that data. So let's take a look at the EMR deployment options. So customers have multiple options to run Amazon EMR. EC2 does give the broadest range of compute instance options in the cloud to allow you to optimize price performance, including the choice of AWS Graviton processors. Graviton is based on ARM Neoverse, and it's really ideal for running machine learning workloads as well. So next we have Amazon EMR on EKS. That provides that automate provisioning, management, as well as scaling of Apache Spark jobs within EKS. EMR on AWS Outposts. If you do want to scale EMR in your own on-prem environment for, whatever compliance reasons that your infrastructure may have, you can do that just as you would on the cloud. And finally, EMR serverless. You can run petabyte scale data analytics in the cloud without really managing and operating some of those clusters. It's running in the back end, so you don't really have to focus on that. So let's talk a little bit about Amazon EMR serverless, right? It's all the benefits of EMR without having to manage those clusters. So we launched the first version of EMR in 2009, which is over 10 years ago, right? And we've been constantly innovating in areas like performance to make sure that EMR is the best place for you to run your Spark workloads, as well as workloads for other frameworks, right? And serverless is an effort to apply what we learned from observing customers using EMR with their EC2 clusters. It's really just simple to use because you don't have to configure, optimize, or operate those clusters. You don't really have to worry about instance types or cluster sizes, security, or even the operating system patching. You simply just specify the framework and the version that you want to use for your application and submit your data processing jobs. So that's really what you have to do as a customer leveraging serverless. You still get all the benefits that you expect out of EMR, that open source compatibility with multiple different platforms, latest open source versions, performance optimized runtime, but without the need, to manage those clusters. There's also no need to guess cluster sizes. Serverless really eliminates the need to right-size your clusters. There's also multi-AZ resiliency, integration with familiar tools, and you can really just optimize on cost since there is automatic and fine-grained scaling, which will reduce costs in the long run. So let's take a look at what and all you can do in the features of EMR serverless. So you can run jobs on applications, and a job is a request submitted to an EMR serverless application that is asynchronously run and tracked through completion, right? You can run multiple jobs concurrently within your application. Workers, so an EMR serverless application internally uses workers to actually run your jobs. By default, each application uses workers with 4 vCPU, 30 memory, and 20 gigabytes of local storage per worker. And you really have the ability to customize this configuration. There's also pre-initialized workers. So EMR serverless provides an optional feature to actually pre-initialize your workers when your application starts up. So you don't really have to worry about the workers being initialized as soon as your application starts. You can pre-initialize it so the jobs start immediately, and it helps you maintain sort of that warm pool. Your workers are up and ready to process those requests as soon as you start up your application. There's no downtime, there's no waiting. So I really wanted to take this slide to not only talk about the differences between Glue and EMR, which we discussed previously, but also the differences between serverless, EMR and EC2, and EKS, and why and when you should choose to deploy. You should choose a certain deployment feature. So with EMR serverless, fully managed, as well as that interactive analysis with Studio. With EMR and EC2, that startup time is a little bit longer than serverless, but you do have auto scaling with custom policies, as well as managed scaling features. So you're really in control. You have more of that autonomy with EMR on EC2 in terms of scaling, as well as different customizations, and you can have more options for interactively analyzing your jobs with SageMaker Studio and things like that. With EKS, you have that integration with Studio as well as desktop-based notebooks. And there are some limitations with each service, which makes, one more advantageous than the other based on your use case, right? So let's take a look at SageMaker and EMR and why you would want to integrate both. For those of you that weren't there in the previous office hours, I just wanted to do a quick overview. So Amazon SageMaker is a comprehensive machine learning service that enables, business analysts, data scientists, engineers to build, train, and deploy their machine learning models for any use case, right? Regardless of machine learning expertise. So when it comes to integrating EMR with SageMaker Studio, you're really able to discover, connect to, create, and terminate your EMR clusters. You're also able to bring your own image and customize the notebook lifecycle configurations. Enterprises want to be able to centrally administer data access controls, and you can use data governance tools like AWS Lake Formation to not only do analytics, but do machine learning, side by side concurrently, so that you don't have to do one and the other. You do have that integration to use both at the same time. You can also automate EMR, Glue, and ML pipelines in production concurrently. And again, enforce those fine-grained data source access controls so that, if you have a couple users in your enterprise that you don't want access to EMR or you don't have access to specific, Studio notebooks, you can enable that as well. And Manpreet is going to actually show a demo of SageMaker and EMR as well. So with that, that does conclude the presentation. So if you all have any questions, please feel free to, drop in the chat or ask now. So we'll just give it a couple minutes. But shortly after this, we'll pass it off to Manpinder to do the demo of EMR, as well as that integration with EMR and SageMaker.
Awesome. Thank you so much. And thank you, Shweta. I think it was a great session. Quick introduction about myself. This is Manpinder. I also go by Manny. I'm a solutions architect here at AWS, and I've been with AWS now almost for 7 years. I have started as an infrastructure networking engineer and then moved on to big data. And then, I spent another year in AWS Commerce Platform as a data engineer. And then I've been working as a solutions architect, helping enterprise customers for past almost 2 years. So thank you, everyone. Thank you for the opportunity. What I'm going to do here is I have the console, and I hope everyone can see my screen. And I'm sorry, I'm not looking directly into the camera because I have multiple screens, and I'm trying to look at the one which has console. So I'll try to walk over EMR setup, how it is staged, different flavors of EMR, and I'm going to keep technical stuff at probably 100 to 200 level, because I think on EMR, maybe I can spend a whole day if you want to demo. It's a very extensive service. And I myself I'm still always learning. There's so much things within EMR. But yeah, feel free to ask any questions within the chat, or I think Shweta probably would share the slide deck that should have our email. Feel free to reach out to us as well for any questions you have. Okay. All right. So to begin with, just like any other AWS service, we give control over EMR through console. You log into AWS console. You can access EMR. I am already there. So this is the console, and obviously through CLI as well. Whatever we will be doing through console, it can be done through AWS CLI. And there are a lot of customers out there which actually utilize that. And I'll go over those things. Primarily, it comes in three flavors: EMR on EC2. This is traditionally, it's been around, as Shweta mentioned, since 2009. EMR has been one of our oldest service and quite widely used, within the big data platform. Then with we also have a flavor called EMR on EKS. EMR on EC2, when a cluster is provisioned, you would see EC2 machines in your own account, which will be actually, so we will be managing provisioning, bootstrapping, configuring all those machines with the required applications to run a Hadoop cluster. EMR on EKS, EMR on EKS would use, it's a virtual cluster. What it is, there are some use cases and some customers out there which loved, presence of data on Kubernetes. So that's when we came up with EMR on EKS. So with that, you actually would have an EKS. I don't have an EKS cluster provision right now. I just wanted to keep the demo light. With EMR and EKS, you would have an EKS cluster, Kubernetes cluster. And when I say EKS, it's a abbreviation for our Elastic Kubernetes service. It's a service that, again, AWS offers. If I just look for this is the one. So EMR on EKS is backed by that. So you would have an EKS cluster running in your account, and then you can basically tie your EMR cluster with that EKS namespace that you probably would have provisioned. And then EMR serverless. EMR serverless, again, everything with serverless growing. So we did came up with EMR serverless. In this, you don't really, you would, so EMR on EC2 and EMR on EKS is more like a managed offering where you still have some compute tied to your account. But EMR serverless is totally service. So it's a fully managed and serverless where you wouldn't see compute in your own account, but you would just be submitting jobs, applications directly to EMR serverless. Again, different use cases. Few of the use cases, basic use cases that I can go through. It is always recommended to use EMR serverless when you have a use case which has a specific application requirement like Spark, Hive, Presto, Trinio, which comes in serverless. Not all the flavors that exist on EMR on EC2 or EMR on EKS, you might not see all of those flavors right away in EMR serverless. So first you have to make sure that it exists. And then if your workload is spiky, try to use EMR serverless. But if you know that you have a very consistent workload, you're going to be using compute probably 24 hours a day. You know what kind of compute you would be using. Probably you folks might have been running those Hadoop cluster on-prem, so you know your usage pattern. So for consistent workloads, try to use EMR on EC2. It would be again, it's not a rule of thumb, but usually when you have consistent workloads, using a provisioned infrastructure can be more economical than serverless, and that's kind of I think stands true for in general, like serverless or provisioned compute. So what I have is so I'll try to cover how cluster is provisioned, and it takes like 15 to 20 minutes. I already have few clusters provisioned in my account. You can see here, and few terminated as well. But let's see if I had to provision a cluster from scratch, what all it asks for, what are the basic things that we need to configure. So if I click on create cluster, and then this is what it comes up with. You define your name. There are different releases of EMR. We are always releasing, upgrading these releases, and primarily what we are doing in this releases is we are making sure that we are capturing all the updates in the open source world, and obviously from the application side, like Hadoop, Spark, Hive, Trinio, and also we are also capturing all the updates from the operating system side. It's a managed offering, so we take care of I mean, when you provision the AMI that is used to provision those EC2, we make sure we are updating that, and as well as making sure that we are upgrading all the features that might be coming up in the open source world in any of the application like Spark or Trinio, any other frameworks as well. Once you have that, then we have bundles. If you select Spark, you will see all these applications, Spark and Zeppelin by default selected. If I just do core Hadoop, it's going to select Hue, Tez, Hadoop, Pig, Hive, Trinio. Just based on what you're choosing, it is flipping those check marks. Again, those check marks means that when the cluster is being provisioned, it is going to install Trinio. So let's just try to use custom. Usually, what I've seen in my experience, if you're trying to provision a Spark cluster, try to keep Hadoop, try to obviously choose Spark as well, and then you have Hive. It's up to you. And then if you want notebooks integration, make sure you have Jupyter Hub and then Jupyter Enterprise Gateway. So if you want to integrate EMR cluster with an external notebook, and in that external notebook, we have SageMaker as well. So we need to ensure whichever EMR cluster needs to be integrated with SageMaker, Jupyter Enterprise Gateway needs to be selected. This is the layer which will provide that integration, which will act as that integration layer from SageMaker to EMR or any other external notebook as well. It'll give you that. Glue data catalog settings. So while provisioning cluster, obviously, in a big data platform, you need a catalog as well. So by default, there is a Hive store which gets installed on the cluster on the master node. By default, it's a MySQL process running on the master node, which by default, if you don't choose Glue as your external data catalog, that MySQL running on the master node would be acting as your data catalog. But obviously, because we provide native integration to Glue, it's always recommended to use this. This provides quite a bit of flexibility. For example, let's say your cluster got terminated, and if you had your catalog on the primary of your EMR cluster, your catalog would be lost. But now, if you had an external catalog, as Glue, then if you terminate your cluster, your catalog is still there, and then you can just provision a new cluster pointing to the same Glue catalog in the same account and same region. You should be good. You don't need to then worry that much about that. Cluster configuration. So from compute, from resource sizes, we offer two different options: instance groups and instance fleets. And I see there was a question as well in the chat. With an instance group, we give you an option to choose an EC2 instance type. Again, primarily this is divided into three layers: primary node, core node, task node. So primary is the master. It's the master of your EMR cluster. And when I say master, so from Hadoop perspective, Yarn resource manager would be running on this. From HDFS perspective, name node will be running on this. So those will be the processes that will be running on the primary node. And now we also have an option to do a multi-master. You can click this, and it will provision a multi-master node. Core node, core is the one which comes with it will be running from Hadoop perspective, Yarn and node manager. So Yarn resource manager is the master for Yarn world, Hadoop world, and Yarn node manager is the one which interacts with the Yarn resource manager. And data node. So data node will be, this is the HDFS data node as well. when I say data node, this will, if you are saving data on HDFS, utilizing local storage, EBS volumes, your data will be stored on these core nodes. And obviously, name node is still there. Metadata for HDFS will be on the name node, which is on master. Then we have another flavor, task. Task is a little bit different from core. So we expect customers to use task, considering that it does not come with HDFS. It still has the yarn node manager. It can act as your compute. It can provide that memory and vCPUs, but it won't have any. Don't expect it to persist any local data. Obviously, it will have EBS volumes. You can use that as a temp storage in your applications, but it won't. Your HDFS is not extended into task. So it's always a good idea to start with the few core nodes, depending upon the data that you're trying to utilize. Like, let's say you're trying to utilize 100 gig of data. So accordingly, try to provision those many, a particular instance type and those many EBS volumes. And then outside of that, let's say for the compute, you can provision task nodes. It'll be more economical, because then you don't need to add those many extra core nodes, because then you'll be paying for EBS. Instead, add X amount of task nodes. And again, for primary, because a primary master node won't be doing a lot of memory heavy operations. It's not handling the data. It is more like, coordinating stuff. Again, obviously, depending upon if you exclusively deploy a Spark driver on primary, then you can expect memory utilization. Otherwise, mostly it will be vCPUs which will be utilized. So you can use a general purpose instance type like M5 or M5X, M5 2X. Again, based on you have to benchmark that what suits your use case. For core and task, we recommend using instances which are maybe R memory optimized, because we expect in big data world that memory is the biggest driver when data is actually being transformed or being computed. So it's always a good idea to start with a memory optimized instance for core and for task, both of them. And then we also have an option here within these EC2 instance types. We can also choose spot instances instead of on-demand instances. Again, consider this as because it's going to run EC2 instances in your account. So for you, the best strategy on EC2 would be, if you have consistent workload, fix your instance type, have your instances reserved, make sure that you are paying that reserved instances pricing, so that you can, save on the on-demand cost. Or if you have workloads in which your SLA is not aggressive, let's say you have a Spark job running on weekends, which does not have an aggressive SLA. It doesn't really matter that it completes that Spark job in the afternoon or in the morning or in the night. All it matters is it just completes that Spark job on the weekend. So for those kind of workloads, you can have an EMR cluster with more spot instances. You can have a mix of both in both of these core nodes and task nodes. You can have few on demands or few spot, but again, where you have which you don't really where you don't have those aggressive SLAs, try to use spot instances. With spot instances, as you folks might be familiar, if the spot capacity is reached, we can take back that spot instance. But then again, the EMR cluster will try to spin up one when there is capacity. So your job will restart itself again, depending on how it is submitted. Moving on to the next one, cluster scaling. Obviously, obviously in dev environments, start with instance sizes 2, 3, whatever suits you. We have something called EMR managed scaling. What we do here is if you enable this, we'll ask you to provide an IAM role. So EMR service will itself look at few of the CloudWatch metrics. Few of the CloudWatch metrics like yarn, total memory, container pending ratio, and based on those metrics, it will try to scale up or scale down based on whatever metrics based on the metrics that by default EMR service will use. And then there is use custom automatic scaling as well. So if you select this, then basically it can do scaling for you, but you can also define which custom CloudWatch metrics you care about. So you might only care about yarn memory. It's always a good idea to give a couple of CloudWatch metrics. So, but in here you would have flexibility to leverage other CloudWatch metrics. EMR managed scaling, it comes by default with it's going to look at X amount of CloudWatch metrics, and based on that it will do the scaling. And we have a documentation as well. Here is the documentation. It talks about all the metrics: apps pending, apps running, container allocated, pending ratio, STF utilization. So based on this, it will flip up and flip down. Again, pretty much like any other VPC, define a subnet, and I'm not passing any steps. I'll try to cover steps in a couple of minutes. Then what kind of cluster termination policy you want. You want to terminate the cluster or automatically terminate the cluster if it's idle. So this is also quite useful when you're using workloads which are not consistently running, and when you don't have obviously data on your local EBS volumes on HDFS nodes. Because if you select this and if you had data on EBS volumes, its cluster is destroyed. Your EBS volumes are also gone. And then cluster logs, define where you want to pump out the logs that the service and the applications is producing. Select an S3 location if you want to define the tags, and pretty much that's it. I think define a EC2 key pair as well if you want to SSH into those nodes. And once you have defined this, if you have, again, like any other service, you have to define roles. If it's a new setup, create a service role, new service role, create an instance profile. So the service role is the one. This will be assumed by our EMR service to do tasks in your account. For example, spinning up an EC2 instance in a core node, or spinning up EC2 instance in a task node, or terminating an EC2 instance, such stuff like that. An instance profile is the role which will go on your EC2 instances, which are deployed within your EMR cluster. Once all of that is defined, you hit create cluster. It takes around 15 to 20 minutes to deploy one. I already have deployed few clusters. If I just click on this is how it looks like by default. It gives you the options on this upper page right here. It gives you the option on how to connect to primary node using SSH. You just like EC2 instances, basically you can SSH using Hadoop as a user. And obviously you would have to define EC2 key pair in the beginning. You can use this command, and we will try to connect. I have a Cloud9 Cloud Shell running in my account. Let me try to quickly see if I'm still connected. Okay. All right, so just like any other SSH command, if I give this command, it's going to let me into EMR cluster. And I can do this from my local machine as well. I'm just using a cloud instance right now to do the same, but I can do this through my local machine terminal. So pretty much what I'm doing is, if you see here instance hardware, this is an instance. This is an EMR cluster which I have deployed with only one primary node, one core node, and one task node. And if you see here, this is the EC2 instance. And if I open this in a new tab, it's going to, flip me back to the EC2 console. Yep, I think it's taking time, or let me just try to. So anyways, yeah. So you can see like all of these instances, I'm not running anything else except obviously my Cloud Shell environment. which this is the instance which is tied to that, but everything else here is are my EC2 instances which are tied to my EMR cluster. And you can see here uh, when the steps to connect to primary node, this is actually a public IP of my master node, 3589.28.255.4. So I'm just trying to connect to that. Let's try to do one quick thing now. I already have an S3 bucket in my account. What I'll try to do is I have CSV file here in this S3 bucket, which is a New York taxi trip data. What I'll try to do, I have a Spark ETL script, which will read from this, and then it will write back here to an output location. So we'll try to see how you can submit that. I mean, it's a very simple job. Again, I'm not focusing on the ETL itself. You can have as much as of complex ETL jobs, but I'm focusing on how you can submit those jobs. So first being, obviously, let's try to submit it from within the master node. So I'm already connected to my master node. I'm SSH'd into it. So what we will do now is, and this is my ETL job, spark etl.py. Just to show you, it's right here. It's trying to read, and while reading, it's going to infer schema as well. I'm just using Spark method, and then what we will be doing, we'll be updating the, we'll be adding another column, appending another column to each row with current date and time. That's it, and it'll print schema, and then it'll show that data frame. Again, not focusing on the job itself, but let's try to submit that. And I think I already have this ETL job here. Yep, if you see, if I do a list, let me bring this up. I already have this, and I will just use this very simple Spark submit command, which will execute this, and I'm passing in two arguments, Spark, where I'm giving the input location and output location, and these arguments are being utilized in my ETL script. You can see here it's going to pick the input folder and output folder based on the arguments and I'm passing. So if I just hit enter, because I'm submitting this through my shell, the Spark driver is initialized here. So this is going to give all the logs. See, AM container is launched. This is actually the driver. So that's what I was talking about. If I am submitting a job like this, now on my master, I'm also utilizing my memory, because all this is coming from my Spark driver. It's a Spark application, and I'm expecting that my driver is also now utilizing memory. So this is where it generated that a data frame show, like where it's trying to show what all is within the CSV, vendor ID, pickup date time, drop off location, store, what was the rate, and stuff like that. But again, it will continuously keep processing. There are what we are looking here now. If you are running these jobs in an actual environment, how would you look into application logs? Multiple ways to do that. The easiest one, obviously, one is we already saw here. They are the driver logs. Easiest one is you go to Yarn timeline server. It's going to take a second to launch. All right, so here you go. So because I already processed few jobs earlier, you can see I can see application 001, 002. These were already succeeded, and these are the ones which I ran yesterday. This is the one which we just submitted, and it shows as running right now, although it is actually completed. If I go to, let's say, the same output, I can see it converted those files to Spark A before writing as well, because that was in my code. And in here, I can, it takes like a couple of 2 to 3 minutes, because what it is doing, it is now this yarn timeline server. It is reading from log location to see what's the state of the job. And if we refresh, yep, I can see now it's finished. If I click on this, you can click on logs. You can further click on attempt. You can see there were 1, 2, 3, 4 containers which were launched against this. And if I click on any container, I can also click on logs. I think my JavaScript might not be enabled here, but yeah, you will be able to browse through all of this, and you'll be able to see different logs from this. And obviously, remember in the beginning when we were deploying, we also selected log location for all of. Let me see where we can. Here, so log destination. We'll also see all of these logs here. This is in S3. It's all pushing out all of these things here as well. So we have a daemon which is called instance state. It runs on each of the EMR node. That daemon is pushing out all these logs, and there are other daemons as well. Obviously piping those logs and everything. There are multiple daemons that you will see on each node of EMR cluster, which is specifically to our service. Instance state is one of that, and then instance controller. So if you will do list services on a node, you will see an instance controller daemon. That is the daemon which interacts with our control plane on our and on AWS side. So let's try to now, again, I just wanted to give, just like Yarn Timeline Server, you can also access Spark History Server. It comes with your EMR cluster. Spark History is again running on master. It will try to connect to that. If you are more familiar with looking at Spark History, you can look into that. Yeah, here. So different consoles probably giving out the same thing, but obviously because it was a Spark job, it's going to also give you a lot more information about the job. These were all the stages between my job. I mean, the first stage was 0. I mean, if you go from bottom to top, it used a native Spark method to read the CSV. Then it account as well. We had all these methods, and then before writing, it says Spark at native method. So that was the class which was called to process that operation. So it gives you all of that breakdown. Executors in Spark UI, this gives you a lot of information. So these are the actual Spark executors, Spark containers processing that data, including Spark driver. And you can see here, driver, the first one is driver. It was running, if you will check this IP, this was running on the master because I submitted from Spark submit. And then these were the 2 executors. These were the ones which were actually doing all of the work to do that computation. And you can look at these jobs logs. Let's try to do one more quick thing. So this was one way of submitting a job, a very I would say the most basic way. And now the more flexible way or more utilized way is EMR step. So we have something called EMR step. If you add a step, so click on add a step, and you can do this through CLI as well. Click on step, give a job name. Let's see, test. Again, I already have an ETL script in my S3 bucket. I gave that, and then in here, I'll pass in the same command, Spark submit. So what step is doing, it will, oh, sorry, let me try to change this. This is command. This is the jar which is actually needed to process that. So I'm just submitting a Spark submit ETL job here. Yep. And then if action step fails, continue, cancel, or wait. Again, what it will do is it will submit the step, how step is processed. There is a jar, there is a class jar file on EMR master. It will take that input, process it, see what command it needs to process. And because I'm submitting a Spark job, it will, as soon as I hit add step, it will start processing it. And if step fails, continue. Like if your job has failed, if you want to do nothing, just continue, cancel and wait. Cancel if any of the step failed, cancel all the next steps and then wait until someone looks at it. And then there is also an option to terminate the cluster. You can actually terminate the cluster if a step fails. If you were using non-persistent clusters and you were, while provisioning the cluster, you were trying to submit a step and the step actually failed, you don't want the cluster to be sitting there. Just terminate it. You don't have any persistent data sitting on there. I already have a step run which I processed, and this is where again with the similar commands, command -runner.jar, and again this is required because this is the jar which is actually going to process this step. Spark submit, again defining the ETL script and input and output files, and then I see I have logs here as well. So whatever logs we were seeing on the shell now is actually saved in with an EMR step S3 location. I'm again, it's piping all these things through S3 by default. So two different ways to submit the same job. Again, primarily it was doing the same thing. Again, I'm not trying to focus on the job. There are so many different things that you can do on a cluster. I'm just trying to focus from an infrastructure layer. Most widely, I would say, when you're actually when you're actually using EMR cluster, or when you're trying to define data workflows, step is more convenient. So we actually, let's say you have a Apache Airflow environment where when a file lands in an X location, you want to trigger a job. We do provide an API within EMR world, which is called run job flow. So if you see, this API is quite heavy from request variables. So you can define all these requests. What this API does is, within the API, you can define all the parameters for your EMR cluster, like what kind of EMR cluster you want to provision. So with a single API, you can provision the EMR cluster, as well as you can define an EMR step down here. I mean, if I show you here, so here is where you are defining the EMR step, which can be a Spark application or any other big application, whichever framework you're using. And then you can define, after your step is processed, do you want to terminate the cluster, or you want to continue, persist the cluster. This is a very useful API, run job flow API. This is the most used API in your workflow orchestrations. Again, you have to account that when you're submitting this API, you have to take into account those 15 to 20 minutes that is required for provisioning the cluster as well. But it's a single call which lets you provision the cluster as well as pass the ETL job that you were trying to process. And this comes in handy when you are defining your data workflows, orchestration layers. All right, so let me close this. Let me now quickly, I think, what's the time? Let me do it 9:50. I'm going to take another maybe 5 minutes. So I think you folks already went through a SageMaker demo. I have a studio domain. I quickly I'll just take another 2 to 3 minutes to show how SageMaker can interact with EMR. And anyways, in a lot of scenarios, it is quite important. I have my SageMaker Studio already opened. If you see, as soon as you go to SageMaker Studio, there is an option called Data, and then you go to Clusters. You can see, I can see my clusters here. So these are my EMR clusters. From within the SageMaker Studio, I can see my EMR clusters. And how you there is, before you can see that, you have to ensure, like, let's look at user profile. So let's say for this default user within my studio, this is the IAM role that is attached. Let me quickly go to IAM. And these are the necessary steps. You have to ensure that you have the required permissions on the role which is on your, used by your users in your studio. So if you see, I'm within this role, and this is an inline policy. This inline policy is granting access to EMR APIs. For example, list instances, describe cluster, create cluster, create persistence app UI, list clusters. If you don't have these permissions, you won't be able to see these clusters here. Again, I have these very granular permissions. You can give more aggressive permissions, although we don't recommend it. We always recommend to use a least privilege model. So I have these very granular permissions which were required for what I was trying to show. So listing out cluster is one. You can see all these clusters here. If I wanted to create a cluster, I click on cluster and there is a template here. And what this template is nothing but a service catalog portfolio. So we have an AWS service called service catalog, which is a a front end for your cloud formation products or cloud formation. I mean, on the back end, it has to be tied to either a cloud formation or a CDK code. So in here, if I click on portfolios, I already had these. If I didn't had these, while for create cluster call, I won't see anything. It will ask me to create those things. So I already came up, because it takes time to provision these. Sorry, here. So if I look at the product, it takes time to provision these YAML files and then set this up. So I already came up with all these provisions in my account. But again, the idea here is if you want that create cluster integration from your studio, you don't necessarily need to. I mean, you can have a team provisioning all of that infrastructure, and maybe your data science team, all it cares about it needs to see that cluster here. And if you want that create cluster capability, you have to ensure you have that integration. And we have a very extensive documentation on that. We can share that with you. And once we have that, I have a notebook here as well in my SageMaker Studio. Once you have a cluster which has the required permissions, and in this notebook, the kernel I have instantiated is PySpark from Spark Magic Image. Again, by default, it comes within the SageMaker world. If I click on clusters, if I click on SageMaker and I do connect, there you go. So that should be good. Again, this is providing me all of that connectivity. Obviously, it's asking me for a username and password before it connects. Initiating EMR connection. This is a no auth EMR cluster, so I should be able to. It takes a while before the connection is established, and it will also create the Spark context. Once that is done, now within my notebook, whatever I'm processing, I'm not going to process all these cells, but now when I will be processing this, the compute for the processing will be used, will be my EMR cluster. So my notebook won't be actually processing all of that. It is just a notebook which is integrating directly with my EMR cluster. And how it comes in handy is few of scenarios. As a data scientist, obviously, let's say you're trying to use SageMaker Studio notebooks more for data science workloads where you're not doing lot of data transformations or not heavy big data transformation. So then you're good. You probably don't necessarily need to integrate an EMR cluster. You can choose an instance type for the for the notebook, and they are quite a big instance type as well. So that could suffice. But when you have use cases, when your data scientist personas are kind of overlapping with some kind of data engineering world where they are trying to process those uh, heavy compute jobs, and usually in an ideal world, that heavy lifting is usually done by data engineers. Then you your local instances on which this notebook is running cannot sustain because it's a single, it's not a distributed, uh, doesn't come with distributed compute. It is a single EC2 instance on the back end. You will have memory limits and you won't be able to process that data at scale from SageMaker. So then it's always good to uh, have that integration with your EMR cluster. I mean, that's one of the way. I mean, you can have that integration with Glue as well if you were just using PySpark, but that's one of the way to have that integration with the EMR cluster and let users submit jobs or commands, do that PySpark transformation and let users use the EMR compute. So yeah, I mean, that's in nutshell, I mean, how that integration happens. And we have something called Data Wrangler as well within this SageMaker. I think you folks might have already covered. You can also, again, leverage that cluster compute while defining your data flows within Data Wrangler. And if your flows have heavy data computation, then ensuring that you have a big data cluster backing that up, or other service like Glue backing that up. So I'll take a pause here. I think I'll try to stop here because I think I can maybe spend another 2-3 hours on just going on so many other things. But any questions, I'll be glad to answer. And what I'll also do, Shweta, I'll share a workshop with you as well. It's a public workshop on EMR. Let me actually share this in the chat. This comes with the detailed steps and how to maybe provision an EMR cluster, how to use different ways to submit a job, or how to use EMR Studio. And we can also try to cover these things maybe in a separate session if anyone is interested.
Thank you, Mani. Thank
No
you for
problem.
this wonderful demo. Amazing. Thank you, Sveta, for the presentation as well. That's all for today, folks. So we covered today EMR as one of the services that you can utilize in AWS to work with Apache Spark, Presto, Hive workloads, right? So you're more than free to use this service during the Datathon. That's why we're doing these office hours, so you guys can have a better understanding of this service. So later today, I'm gonna be sending a follow-up email with a compilation of all the links that we shared today. And also we're gonna be sharing a survey as well for you to tell us how we did today, how we can improve for the next sessions. So we're gonna have a next session next Wednesday, the 25th, and it's gonna be about Amazon AWS Glue, Amazon Athena, and Amazon QuickSight. And also we're gonna be covering other visualization tools like Tableau and Power BI, if we have the time for that. So does anyone have any questions before we finish today? Clarence, is there anything that you want to say?
So
If you're
I
still
just want to
there?
thank everyone. Just want to thank everyone for coming today, and I want to thank Dinesh, Shweta, and Manny for the great presentation, and Ezel for the great
Yeah.
presentation today. And thanks for doing this, guys. It's a big help. And even we get a lot of viewers of the recordings too. So this is very helpful. And thanks again, guys.
Thank you.
Okay. See you guys next Wednesday.
Bye. Thank you.